So as you know, we have the Cloud Mesh repositories, and one of the repositories is Cloud Mesh Storage, which we will be talking next about. Under Cloud Mesh Storage, you find our usual structure that we have introduced you with the CMS, the sys command generate, where if you were to create a command, such as your first name, we create a Cloud Mesh directory. Under these, we have the command name, and then we have the command folder. In that, we have the command name.py. And in this way, we created a storage command. Now, what we have done is, this is prior to the project, we have identified what it actually means to have a storage command. And we, as a group, with 5 or 6 students together and myself, we came up with this definition of the storage command that needs to be implemented. We know when we are on a local file system that we have create a directory. We have, when we have 2 computers involved, get me a file from one computer and copy it to the other one. We not only have the get operation, but the put operation, which is the exact opposite. Then we have the list function, where we go out and list, for example, a directory. Think about mkdir on the Linux system, or the dir command on the Windows system. We naturally want to delete a file. We want to search a file. We may actually have 2 different machines or cloud services in which we store file system, and we want to sync from the source to destination. And we want to figure out what the current status is of the sync process, because that could be taking a very long time. And think about this as the rsync command in Linux, which is very well known. And the students with me together have to naturally figure out what all these commands mean. And that's one of your first tasks, to figure this out. Naturally, at one point, we want to actually configure a storage service. So we have a configuration file simply saying, okay, here is a computer. That computer has the storage a volume that we may call A. And on the other computer, we have a storage volume, maybe B. And then we can simply say, this is copy files from A to B and specify the appropriate directory location. That's what the students have actually implemented in that particular class. And all these commands here are defined, and they are going out to these provider search, provider delete, provider list, and so forth. If you remember what we have done with the multipass assignment and Cloud Mesh multipass, that's exactly the same thing. Just that in multipass, it was start up a virtual machine or an instance on the local computer. So it was maybe run or list or flavors or whatever other command we had. But in principle, this is the same thing. So you have a template already learned how we actually implement these things. Now, if it's not the storage command, but maybe attaching a volume to a thing, it's the same thing. So you start first out, we are creating a volume command, and I may, after this class, create this volume directory, and each student that works on this will be able to help first defining what that volume command actually means, and then we start at one point implementing that. And split up tasks, for example. Now, the good news about this is we have in the Cloud Mesh storage also a provider included. That provider is available for AWS, for Azure, for Box, for Google Drive, and the local file system. And there is actually a storage provider there, yeah, as you can see. That storage provider, dependent on a string value that I can pass along, starts up the appropriate provider either for AWS or Box or something like this. So when you go into, for example, AWS, you see the provider. As you can see from this line here, the provider is being read in here from our location here, the AWS 3 provider, and we import the provider, so this provider, and put it to AWS provider, and then our class called self.p for provider is being instantiated with the appropriate provider itself that puts in the functionality in so that we can call in here, for example, create a directory, create a list, and so forth. How is this now being done? If you are in the provider, we have a storage ABC class that is being put in here. And as you can see, this comes from here. And what we do is we implement for each provider or cloud these commands or these function methods that we have defined need to be generally available, such as create dir, list, put, get, delete, search, and tree. And as you recall, these are things that we need to be integrating into, for example, the command line. So we have these functions designed. And then we have not only a list on the current directory, but also a list of all files recursively in that directory. And we have some restrictions on this. Do you only want to list the directories, or do you want to also list all the files within these directories? This is something that the students have designed with us interactively throughout the class. So we improved this within like 2 weeks or so, and then they started all implementing them. And if they found an error to be done, that is and then improved. Now, the one thing that actually exists is that these students have done, when you look, for example, at the provider in AWS 3, if you look at the implementation of, for example, list the directory, they put a recursive walkthrough through the entire directory. And instead of doing that, it will copy each file one by one when they find it. But I think the better method would be if we were to have, for example, a list function or a copy function, to first find out which files need to be copied, put them all into a queue, and then execute the particular queue. And the nice thing about this is we have already done the queuing function here as a prototype, where we have a storage queue, where all of this queuing stuff is being done, and these files are being simply added to a queue. And at the end, we have a run function, where this a built-in mechanism in Python, where we're using a processing pool, where we then execute, for example, the creation of directories and the copy of files or deletion of files in that particular queue, one after another. So the students who are choosing the Cloud Mesh storage will be working in this particular directory and creating a new provider called AWS3-Q. And that's the one that that particular group of students that choose this as their project will be using. That's the rough, very quick overview about this. Again, you will be having some time to digest what I've said here. You don't have to immediately understand what is going on, but you will understand this once you go through the source code and look at this. This is the very first time I show them. This is now the step after you have made a decision which project you're doing, because it's impossible for you guys to understand every single project and every single thing that is happening. So what you will be doing is you will become an expert in, for example, Cloud Mesh storage, or in actually not Cloud Mesh storage, but in cloud storage. And you will be looking into how do you actually implement something like this with the methods that we have already outlined here and improve this particular program. And we will be helping you integrating this. So this is not like you are completely left alone. We will be trying to get you going, and after you're going, and you can do the stuff alone. There are certain interfaces where I will be helping, like for example, the integration of the abstract classes into an abstract provider. By name, I will be programming this, but you will have to more or less, if you have a provider, you have to implement all the methods that are here in this provider, but instead of using the recursive copy, you replace this with a queue. And if you don't like the queue that we have designed here, or if it doesn't meet your needs, then you have to implement a new queue. The Cloud Mesh Volume project is really the same thing, just that we don't have a starting code here. And as I said, I will be creating a Cloud Mesh Volume directory at one point after this meeting. We can just go ahead, and as I said, this is if you're interested in research what a volume is in the cloud, and then come up with a command specification to the volume. And you have seen here the storage one, then we will have your volume, and then create a volume with a name, you know, maybe deactivate a volume. Whatever is needed in order to manage a volume on a cloud. And we want to have this as a command line first, because this gives you the abstract interface very easily, how you would be interacting with this. And it's easy to think about this from the command line, because then you can simply add new features here as the project goes. So we have also a project that's called Cloud Mesh Cloud. So let me find that. In Cloud Mesh Cloud, you find under abstract classes, that's something that you already have seen from the multipath experiment. You have start, stop, info. Here's about how do you manage virtual machines. And for a cloud provider, these methods have to be implemented, all of them. And one of the things that we have is we have here under compute, a libcloud provider. And this libcloud provider includes here a Google libcloud provider and has most of these methods, not all of them, already implemented. However, we would like to replace everything that we have done here with Google specific APIs. And you can certainly look into Cloud Mesh-Oracle or Cloud Mesh-Azure or Cloud Mesh-AWS, where we have actually done this. And what we want you to do is you will be re-implementing that provider. There may not be even a reason to even look into this here, so you may get inspired what we are doing here, but likely the entire code has to be replaced. And this is relatively straightforward because most of the functions are relatively easy. The only things that are making a little bit challenging are here, for example, how do you deal with security groups or keys? That's something that students typically struggle. All the other functions are really easy to implement. So what I would be saying is try to get as many methods as possible, quickly implemented, and then work with us on the keys and the security groups. And naturally, you need to be understanding these concepts as every other student from this class. However, you will be having a little bit more knowledge about this because you will be implementing this. And this, as I said, you will not use libcloud as the implementation Python API, but you will be looking in Google and find out what Google actually uses. And then what you will have is you will be doing that particular code development in Cloud Mesh Google over here. And there is only storage at this time included. And what we will be doing is we will be adding here a compute directory and put a new provider in there in which you will be working. And we initialize this with what similar to what we have done for multipath. Are there any questions concerning?
Yes, Professor, the last project which you explained, has that already been taken by someone? Do you know?
I have no problem having 2 people working on this. So okay. What you ought to do is go into the spreadsheet and take a look if it's already been taken. If it's already been taken, then put your name underneath that, and put your name there. And this works exactly like the multipath project. Whoever develops the stuff first, that's probably what we take. If there's a guy that develops everything first, then the question becomes, are you guys not communicating so that you can not split up your tasks? For example, one guy does the key management, the other one does security groups, the next one does images and flavors. So I think it's easy to split this up and have this project done in a relatively short period of time. So good. Yeah.
Professor, so what's the difference between Cloud Mesh storage and Cloud Mesh local compute and storage?
Cloud Mesh compute deals with starting up of virtual machines. Okay. Cloud Mesh storage deals with how do you copy file systems from one cloud to another cloud.
Okay.
So they are not related. So they're related because they're on the clouds, but the one deals with maybe AWS 3 buckets, the other one deals with the Oracle buckets and Azure file systems. So they are not necessarily related. They're related because the outline of the project is 100% the same. So you have Cloud Mesh, Google Command. Here you have Cloud Mesh, Google Storage. They happen to take place in the same bundle, if you so want, or repository, because they're related to Google.
Okay.
Okay, good. So this was another project that we have. Now let's go to the analytics project. The analytics project looks to be initially the most complicated one, and we have a super sophisticated code in here that has been developed by 2 excellent students from last semester. However, it's so sophisticated that we may want to take another look at this, and this is what we are doing this semester. We want to simplify this. And instead of you looking at what they have actually implemented, I don't want you to do this initially. I want you to understand first what the problem is. And that's easy to do, excuse me, because I've already pointed that out yesterday in the lecture, and you can re-watch the lecture. However, since then, I hope we have done some modifications. So I do git pull. First of all, we know how in Python we can formulate functions. This is the function definition that is being used in Python 3, where we can augment the function parameters with data types, such as integer, float, and maybe even more complex data types. So it will be up to you to look up the specification in Python on how to do this. And there may be much more complicated things with, for example, maybe classes as parameters and so forth. And you need to be figuring out how to do these kind of things. Then the function has a docstring and a calculation. Here in this case, I just simply returned the number 1. But this could be a call to maybe scikit-learn for k-means, and k-means has a fairly complex parameter set. But let's assume we have an arbitrary function with a name and some parameters that returns some value. The question now is can we use this particular function and automatically create a REST service out of it that we host on Amazon, Azure, Google, and any other cloud that we have providers for example, Cloud Mesh? And how would we do that? And we have a really simple way of doing that. And the way that we do this is not only can we actually stage this as a Python program, but we can stage this as a Go program, or as a Kotlin program, or as a Java program, or as any other program, because we could be using the specification that we generate in Python to this particular code into another language, and then we can create clients that easily interface with that particular tool, or we could be creating a base service that uses this and starts within that particular service Python to do the calculation. Or we replace the calculation with something faster, maybe there's a special version of that particular function created in machine language so that we can, for example, get some super fast results when we pass certain parameters in and we declare that function appropriately. So having said this, Python has a really super cool mechanism on letting us know, for example, what is our number of arguments in this function. See, what I do is I've declared here a function. I assign the function equal to a. Just I could have here also said a.name. It's the same thing, but I just wanted to have here a mechanism so that I can say, okay, arbitrary name, and then all this other stuff here stays the same. So I just print an empty line, and then I'm, for example, print the name of the function. Then the function has actually a code. The code is the specification of that whole thing, but it has, for example, an argument count. It has variable names. It has the code associated with this, the file name, maybe line number, some flags, and other things. So what I'm doing here is I'm actually exploring what Python knows about this function so that I can use this information to create a specification that is then used to create a web service that is using REST to serve this function as a REST service. That's what we will be learning in class within the next 2 to 3 weeks. And so if you have a question about that, you can already read ahead. There's a section in there that's called Open API. And then the other section that you only need to read is Open API version 3. Don't read the other Open API sections. And then the other one you need to understand is called Open API with introspection. And the introspection is really important because we take the specification and in 10 lines of Python program, we create a REST service out of it automatically without you having to do anything. We just put in the specification in there, and within 10 lines of code, you have a REST service. So when I try to run this now, so I know this may not work because I just experimented with this. So remember, I go to into Cloud Mesh Analytics. I go to tests. I can list the test. I have here the test example. And when I type in Python and do that example, I actually get some values out. So this is very encouraging. So it's good because I've done this at one point. And see what actually happens is when we look at the code here, for f in, and then all these values are being printed. So the first entry would be the name of the function, as you can see, a. Second one would be how many arguments does this function have? 2. The next one is what are the names of these functions, x and y? The next one would be, what are the cell vars? Now you have to understand what that actually means. Now, what is the code of that function? And as you can see, here is the entire code being listed. What are there any constants being defined? Here in this particular case, 7. No, 1, 2, 3, 4, 5, 6 constants. I believe that was 7. Yeah. So in this case, what is that's the file name. Constants is one above. I don't know what the other value now is, but you can find this out. So you see here file name, right? It's elements. You see first line number of the code is line number 5. So if you take a look at this, see this is line number 5, as you can see. So what is the maybe some flags? You have to interpret those. So as you can see, this is relatively straightforward. 19 would be, for example, our docstring. So we can introspect this entire code, and there is one more function there. And this is a really super cool function. It's called annotations. this value underscore annotations now returns us a dict where we can actually see is okay. The first variable is called x, the second variable is called y, and I have a return value that returns an integer. Remember what we did? We looked at this function here at the beginning. This is what we defined, and so we get actually a specification out that tells us what the parameters are and which types they are. Now we have all the information that we need in order to create automatically a REST service out of this if we create some specification. Now, the important part is that when we go to our cloud computing book, here, this particular book, if you go to the section Open API 3, at this time it's still in 6.2, so that section may actually change, but at this time it's Open API 3.0. You need to read that section and you need to be understanding Open API 3.0. We have provided there some specification and given an example here on how that looks like. And you have a title, you have service, you have a path, you have a component, and this component is, for example, the objects that you refer to within this thing, and you will have to understand this in order to use this particular AI service. What you would do is the Python program that you have, you would be converting into such a specification. And once you have such a specification, so we explain here all the different parts of that specification in more detail. You use this section here, Open API REST Service, and it will be surprising to you that with this little program here, you can generate automatically from that specification a REST service. And what you would do is you would be creating here an a.yaml, because our function is called a, so we would be calling here a.yaml, and we include this in this code and complete it with this line here, and that creates us the REST service. Now we need to make sure that we need to create that particular program, and then once we have created this program, we need to host it onto the cloud, and that's easy because we have CloudMesh. CloudMesh has this booting feature where you can boot up a virtual machine on each one of the clouds. We copy then the program over and then run it on the cloud, and then we can conduct performance comparisons between the different cloud services that we have staged all over the place. That will then be integrated in a benchmark test that you do. And because we have so many students, it will be tested on all the programs with the same functions, and each student may be defining another function. In phase 2 of the project, we will also look into, for example, scikit-learn, and look at things such as, for example, k-means. So I see all these students that are submitting projects with k-means to me, and then they give a single example. It's super hard-coded and it's absolutely completely useless. And I reject all these projects from now on. And what we do is instead of worrying about a single k-means application, we worry about how can we include the function k-means as a REST service in the cloud, so that within the cloud service, we are having all these parameters that are being part of our k-means algorithm, and we use that k-means algorithm to calculate our function. At times, we need to also upload data, so there may be some other important information here that is not being captured in this particular k-means. So for example, says, okay, I need to be uploading some data. So we need to copy data from your local file system to the cloud. How can we do this? Well, we have the storage services already implemented in CloudMesh, and so we would be reusing the storage services that are currently exist and copy the data over to that thing. This completes the entire project that I envision for this. And because we have so many students, each student will take then one function and implement this And this can be even different toolkits. This could be, for example, Keras or TensorFlow that we package into such a function. Remember where we started out from? We started out from a function such as this. Assume we have defined this function this way. We then have a program that automatically derives the open API, then derives the REST service, then we can stage this on any arbitrary cloud. So the only thing that we really have to do is define the function, put here our k-means function in there from scikit-learn, and run our wonderful REST service generator on it, and we can have a cloud-hosted scikit-learn program that we can then even integrate in Jupyter notebooks if you want to do this, and have then maybe k-means not running on that particular virtual machine, but maybe on a different cloud, for example. So are there any questions concerning this?
So Professor, everyone who has chosen this project, they have listed down 2 clouds. So what we have to do in that case?
Let's assume you have a function like this, and so you will have to make a benchmark comparison between this function in the 2 clouds that you have chosen.
Okay, this really sounds interesting. So I discussed with you about the Cloud Mesh Compute project few minutes back, but can I work on this project instead of that previous one?
Yes, this one here has a little bit higher expectations. So I have to be honest with this. So this is not a project for someone that actually starts out in the first week of doing Python programming. So the other project is more suitable, is much simpler in that aspect, because we know how to do certain things. Here, the challenge is understanding the open API and deriving from this introspection of the function in Python the open API specification. And the problem you will see is later on will be these data types. So there may be very complex data types in, for example, k-means, and we have to maybe deal with these complex data types in some fashion. There may be even a case which we cannot do, and then we would document that. Okay, we cannot do that. And then the other thing is this is a US student, and maybe I haven't made that particular part clear, have to put some meaningful AI calculation in here. So one of the other things that we have is, for example, Azure has actually a built-in k-means function. So how does that function compare in the benchmark with the function that you have now implemented, for example, using scikit-learn? That's also another aspect. So there can be multifaceted aspects that actually can come that we not yet foresee. But first we need to be implementing something. Once we have implemented that, then we can move forward. And since we have so many students that are interested in this particular project, my hope is that this first transition here can be done relatively quickly. And then we can do more interesting things on the comparative side.
Yes, this really sounds interesting, the way it has been explained.
And I'm not even sure. I mean, this is such a trivial idea. I'm not even sure if someone has already developed these kind of things, right? So, and remember, this is not re-implementing this in Flask. So if someone knows already some Python, they can say, oh, I'm doing this all in Flask. That's not the point. The point is that we generate the open API specification, and from the open API specification, we generate the REST service. And then we staged it. So the amount of Python programming is 10 lines rather than you doing everything in Flask or Django, if you so want. Good. Yeah, you can switch. Just put it in the table.
Sure, Professor. Thank you. So, Professor, on this AI project only, when I see the spreadsheet, students have chosen multiple combinations of cloud services. So can I choose one already existing one, or it needs to be different?
We need to be capturing all of them. However, you split this up amongst each other is somewhat a secondary question, but we need to be capturing all of them.
So I see combinations of AWS and Azure, AWS and Kubernetes, Google and Azure.
Well,
Google
I don't see
AWS.
Oracle there in there. So we need to have captured all clouds: AWS, Azure, Google, OpenStack, Oracle. These are I think the straightforward ones. And naturally your local computer, but the local computer is trivial, right? So there isn't really much to implement.
So can I choose OpenStack and Azure?
Well, if it's free, yes. So
Yeah, it is available at the moment.
Yeah, so then do that. Right?
Okay, thank you.
Yeah, and certainly we want to have overlap, between these things. But if you have 10 people choosing AWS, I will be putting a stop to that one. Yeah. So if you don't have Oracle captured. So if there are already 3 people signed up for AWS, I would be signing up for something else if I were you.